In this video, we'll take a look at section 5.1, linear equations and graphs of linear functions. So an equation is linear if each of the variables in the equation is raised to the power of 1. We've got some examples below. We'll take a minute and look at each example. All right, notice that the ones that are not examples, for example, x times y is not a function, a linear function, because the term on the left is a product of two different variables. D is equal to 16t squared is not linear because the variable t is squared. Okay. So a linear equation in two unknowns has the format ax plus by is equal to c. So the variables, the two unknowns in this instance are x and y. And these are your coordinate. So the coordinate plane, the horizontal axis is x, the vertical axis is y. The values of a, b, and c will be numbers. So something like 2x plus 3y is equal to 5. So those are the type of linear equations that we're going to look at in this chapter. So a solution to the linear equation is a pair of values x and y that make the equation true. There are an infinite number of solutions to a linear equation with two unknowns, and the graph of these points is what makes a straight line. So let's take a look at an example. Find at least 4 solutions to the following equation and graph on a coordinate plane. So our function or equation is 2x minus y minus 4 is equal to 0. To make it easier to find solutions, solve the equation for y. In this case, I added y to each side. So I ended up with y is equal to 2x minus 4. So make a table of values. So you've got a table with your x values, and I selected, the 4 points I selected were -2, 0, 1, and 3 for the x values. Substitute your x values into the equation for the appropriate x, and then you'll end up with a y value. So the solutions are ordered pairs in the form xy. So our solutions here are the points -2, -8, 0, -4, 1, -2, and 3, 2. And notice when I graph these, they're in a straight line. The solid line represents all the solutions to the equations. So the reason why we graph, a graph is all of the solutions to a linear equation, and then your coordinates or your points are single solutions. So recall that the slope of a line, back from chapter 21, between 2 points x1, y1 and x2, y2 is this formula, the difference in your y coordinates divided by the difference in your x coordinates. So if we were going to find the slope of the line above, we would need 2 of our coordinates. So I'm going to pick -2, -8, and pick any other point. Let's see, how about 1, -2? So when we substitute these into the slope formula, we get the difference in y's, -2 minus a -8, divided by the difference in x coordinates, 1 minus a -2. We end up with -2 plus 8 over 1 plus 2, which gives us 6 over 3, which is 2. So the slope of our line is 2. And it doesn't matter which 2 points we picked. In between any 2 points, our slope is going to be 2. It's a constant rate of change. So recall also the slope-intercept form of equation. Y is equal to mx plus b represents the slope m, and b is the y-intercept. The y-intercept is where your graph crosses the y-axis and has the coordinate b. So if you look at the equation that we graphed above, y equals 2x minus 4 has a slope with 2, and we confirm that up here, and a y-intercept of 0, -4. So if we take a look at the graph, 0, -4, and then our slope is 2. You count up 2 to the right 2 to get to any point on the graph. So the reason why this form is convenient is if we know the slope and we know the y-intercept, we can graph without having to make a table of values like we did above. So our next example, we're going to use the slope and the y-intercept of the line, y equals 3/2 x minus 3, to sketch the graph. So we identify our slope, which is 3/2, and our y-intercept is actually the coordinate 0, -3. So when we graph the line, start with the point that we know, 0, -3. That's one point on a line, and the slope tells us where to travel to get to the next point. +3 means we're going to count up 3 over 2, +2 to the right 2. So from this point, we're going to count up 3 to the right 2, and there's another point on our line. We only need 2 points to make a line. If you want to, you can go from here and count up 3 more to the right 3 so that you have a couple of points. Connect. So all you need is the point, any point, and a slope, and you can graph the line. All right, next example is, what if your line is not in slope-intercept form? Well, we're going to go ahead and solve for y to put it in slope-intercept form. So we find the slope and y-intercept of the line. 2x plus 3y is equal to 4. Solve for y. That means we're going to subtract 2x from each side. We end up with 3y is equal to, let's see, that's an x. I'm going to put in the right form, the x term goes first, -2x plus 4. Then divide both sides by 3. That means we divide every term by 3. We end up with y is equal to -2/3 x plus 4/3. And if we wanted to, we could graph by starting with the y-intercept of 0, 4/3, and then using the slope. This is negative this time, so we could count down 2 to the right 3, or you could use the negative on the bottom and count up 2 to the left 3. Either way, you'll get the same thing. All right, the last idea is graphing using x and y-intercepts instead of the slope and a y-intercept. The y-intercept we've talked about. The y-intercept is the point where the graph intersects the y-axis. So what we can do is let x equal 0 and solve for y, and get the coordinate 0, y. We can also find the x-intercept. That's the point where the graph intersects the x-axis, where we let y equal 0 and solve for x. Any 2 points make a line, and sometimes this method might be easier, because you might not need to solve for y. So our last example, use the intercepts to graph the equation. We have x plus 3y is equal to 6. So to find the x-intercept, I'm going to let y equal 0. So I get x plus 3 times 0 is equal to 6, which gives me x is equal to 6. So I have the coordinate 6, 0. Then to find the y-intercept, I'm going to let x equal 0. So I get 0 plus 3y is equal to 6. Divide both sides by 3. We end up with y equals 2. 0, 2 is our y-intercept. Okay, so if it's in the form, the general form, it might be easier to use the intercept method to graph. So we've got 6, 0 as our x-intercept, 0, 2 as our y-intercept, and then if you want another point in here, you could substitute a 2 or a 4 in for x just to make sure. But I'm going to connect these 2 points, and there's the graph of our line. So you only need 2 points to be able to graph the line, and you end up with infinite solutions represented by a picture.